Good evening, dear all. Last class we have completed the exercise problems of exercise 1.1. This class we will see the types of functions. Before entering this chapter, we have to know what is function. Clear? So, what is function? We will see first. Definition of functions we will see first. So, a relation. I am taking a relation f from a set A to a set B is said to be function. Actually, I have taken a relation f from a set A to B is said to be a function. If it is a function means, if it is a function, when it is a function, if every element of set A has one and only one image in set B. Clear? This is the definition of function. Clear? A relation from, actually I am defining a relation. This is my set A and this is my set B. I am going to define a relation from A to B. That relation is f. So for example, I am taking the elements A, B, C here. I am taking the elements 1, 2, 3, 4 here. So A is mapped with 1, B is mapped with 4, C is mapped with 2. Clear? So this is the relation I am taken. So A, 1 is related, B, 3 is related, C, 2 is related. So when it is a function means every element of A, so set elements A, B, C, every element of A has one and only one image in B. It has only one image in B. That is, A has images 1, B has images 4, C has image as 2. Clearly I will draw here, or one more example also we can take. For example, I can take same example. I will take A, B, C, 2, 3, 4. Here one more element D I will take. Clear? So for example, A is related to 2, B is related to 3, C is related to 4, D is not related to any element. So in this case, can you say that it is a function? It is A, B, F is a relation from A to B. Is it a function? No. One more, this also I can do. Now, is it a function? See that A, what is the definition of function? Every element of A has unique image, that is one and only one image in B. See, A has only one image, B has only one image, C has D as image, D has 4 as image. So it is a function. Clear? Similarly, I can take one more example. What is the example I am taking? Means same A as a set, B as a set I am taking. A, B I am taking. Here element 1, 2. A, B, C, 1, 2. A is mapped with 1. B is mapped with 1. And C is mapped with 1, 2. One more element E I can take. Okay, E I can take. See that in this case A is mapped with 1, B is mapped with 1, C is mapped with 2. A is image is 1, B's image is 1, C's image is 2, but E doesn't have any image. So what is the definition here? Every element of A, all the elements of A has one and only in image, but E doesn't have any image. So this F is not a function. F is not a function. So one more example we can say that we will see for not a function. It is set A, same set B I can take. Elements 1, 2, 3. Images here I can take A, B. Here A is mapped with 2. And 1 is mapped with A, and 2 is mapped with B, and 3 is mapped with, I can take C here, 3 is mapped with C. One more element E I can take, that same 3 is mapped with E. This case also definition fails. Why? every element of A has one and only one image. See that 1 has A as image, 2 has B as image, but 3 has two images, C and E. So this case also the definition fails. So we can say that F is not a function. Clear? I think, hope everyone clear which is not function, which is a function. Okay, sir. Every time I am feeling confusing, I feel confused while keeping that function, which is function, not a function. So I will keep an example for that. Actually, first set we keep it as son. Second set we can take it as father. Okay, this is son, this is father. For example, A, B, C. Here you can take 1, 2, 3, 4. So A is mapped with 1, A is mapped with 2, B is mapped with 3, C is mapped with 4, and 5 left unmapped. See that if a father means two father having same child, it is not possible. Because one father, one child possible, one father, one child possible. A father is there without any child, it is also possible. Similarly, one more element I can take D. A child without a father, not possible. So a child without a father, not possible means we can say that it is not a function. That is, our definition is every element of A has one and only one image. This D doesn't have any image. In that case also we can say that it is not a function. Similarly, see that also two father having one same child, it is not possible. So it is, in this case also we can say that it is not a function. That is our definition. By our definition, A has two images, 1 and 2. So like that we can keep son set, father set. We can keep in your mind what is function, what is not of, which is function, which is not a function. Clear? Next we will see types of functions. Now you clear that what is function. Now we will see what are the types of functions we are going to learn in +2. Types of function. So first type is injective or 1-1. 1-1 or injective function or 1-1 function. So we will see the definition first. A function f is from x to y is defined to be 1-1 or injective. A function from x to y is defined to be 1-1 or injective if the images of distinct elements of x under f are distinct. What is the meaning? If the images of distinct element of x under f are distinct. So in other words, how we can say means for every x1 comma x2 belongs to the x first set, then f of x1 equal to f of x2. This should imply, or that implies, x1 equal to x2. What is that? I will read again. There is a function from x to y. So function from x to y. I am defining a function from x to y. Is said to be 1-1 means images of distinct elements of x. If you have taken different images, these are different elements. Distinct element means different elements in x. If you are finding the different elements means that should have distinct images, that is different images. No two elements have same image. For example, A and B I can take. I can say that A is mapped with 1, B is mapped with 1. So A has only one image, B has only one image. This is a function, but it is not a 1-1 function because the images are not distinct. Clear? Images are same. A's image is 1, B's image is 1, so the images are same. So this is not 1-1 function. So if it is not 1-1 means what we can say? It is many one. It is not 1-1 because it is many one. Clear? Understand or not? So now we will see what is onto? Another type of function, another type of function is onto. What is onto function? So see that now the definition of onto. Another name for onto is surjective. Another name for onto is surjective. See that a function f is from x to y is said to be onto. A function f is from x to y is said to be onto or surjective if every element of y is the image of some element of x under f. What is the meaning? That is, if I need to prove, that means for every y belongs to y, there exists an element in x such that f of x equal to y. First we will see what is the definition. Actually, what is the definition? Easily we have to keep in mind. Means this is a set x, this is a set y. I am going to say that this f is a function from x to y is onto, means every element of y. That is, in the second set, this set, if you are taking all the elements, that should be mapped with some element of x. That is, every element of y is the image of some element of x. If I am taking a, means that should be a image of a element here. If I am taking b here, mean that should be a image of some element here. If I am taking c, mean that should be a image of some element here. Clear? Like that I can take. If it is, for example, this also a function, one more element I can take, number 4. Number 4 is mapping with a, mean this also a onto function. Clear? Onto means in only one word we can see all the elements of y is the image of some element of x. That is, if every element of y is the image of some element of x is given. This is the definition of onto. Suppose in problem they are asking what is onto, what is not, how to prove it is onto, not onto. Means if we want to prove onto, we have to show that we have to take a element y in the relation, y in the set, second set. We have to show that f of x equal to y. That is, if I am taking an element here, means we have to show that a element is here, that is mapping c. I need to show that here. Similarly, if I want to prove 1 means I need to take x1 and x2 in the set x. I need to find the value of f of x1 and f of x2. If these two values are equal, then this should imply x1 equal to x2. Symbolically, what I need to prove means I need to take f of x1 equal to f of x2, and then I need to prove x1 equal to x2 for 1. For onto, what we have to prove means I need to take element y from y, then I need to show that f of x equal to y. Clear? This is the definition of 1 and the definition of onto. And some examples also we will see which is 1 which is not 1. Clear? From the arrow diagram we will can understand which is 1 which is not 1. Okay, this is the example given in our book. We will see that this 4 functions, which is 1 function, which is not 1 function, which is onto function, which is not onto function. See that first one, 1 is mapped with a, 2 is mapped with b, 3 is mapped with d, 4 is mapped with c, e and f are left unmapped. So what is the definition of 1? Images of distinct element of x under f are distinct. So 1 has only one image, 2 has only one image, 3 has only one image, 4 has only one image. So I can say that this one is, first one is 1. What about onto? Here onto definition, what? There is a y belongs to y. That is, if I am taking an element in set y, mean that should be a image of some element of x. See that E doesn't have any, E is not a image of any element, f is not a element of any element in x. So we can say that it is not onto. Clear? This is the image of some element, this is the image of some element, C is the image of some element, D is the image of some element, but E and F are not elements of any element in X, so it is not onto. Come to second one. Second diagram, what is that? See, it is 1 1 or not. 1 is mapped with B, 2 is mapped with B. According to our definition, the images are not distinct, because images are same. For the 1 and 2, images are same, so it is not 1 1. I think we have written onto, not onto. Not 1 1. Second one, what about onto? Same. E, A, E, F have doesn't mapped. That is, E, A, E, F is not a image of any element of X. So clearly I can say that it is not onto. Not onto. Next question number 3. What about the 1 1 or onto here? See that 1 have A as image, 2 have A as image, so the images are not distinct. Images are not distinct, so I can say that 3 is not 1 1. 3 is not 1 1. What about onto? A is mapped, B is mapped, C is mapped. That is, A has images. A is a image of some element, 1 or 1 and 2, no problem. Similarly, B is a image of 3, C is a image of 4. No elements left here unmapped, so clearly I can say that it is onto. What about fourth question? The fourth diagram, this diagram, 1 is mapped with B, 2 is mapped with C, 3 is mapped with A, 4 is mapped with D. So all the elements are mapped and the images are also distinct. Clearly I can say that it is 1 1. What about onto? Similarly, there is no element left unmapped. That is, if I am taking any element here, that is the image of some element of X, so it is clearly onto. See that first one is 1 1, not onto. Second one, neither 1 1 nor onto. Third one is not 1 1 but onto. Fourth one is 1 1 and onto. So from here we can derive a definition. If a function is 1 1 and onto, means we can say that the function is bijective function. If a function is 1 1 and onto, means we can say that the function is bijective function, or we can say that the function is 1 1 onto function. Clear? Okay, next video we will see example for that 1 1 function, example for that not 1 1, example for onto, example for not onto, and many exercise problem they will give. They will ask us to prove it is 1 1 but onto, 1 1 not onto. This we will see. Before that we will see how many functions we can make, how many 1 1 functions we can make from X to Y, how many onto functions we can make from X to Y. That is not available in your book, but according to one formula we will calculate all the number of functions. Clear? Okay, thank you all.